Our video tutorial today is about continuity of a function at a number. The function f is said to be continuous at a number if and only if the following conditions are satisfied. First, f of a must exist. Second, the limit of f of x as x approaches to a exists. And lastly, the limit of f of x as x approaches to a is equals to f of a. If one or more of these three conditions fails to hold at a, the function f is said to be discontinuous. Example number 1. Given a piecewise function of g of x, 3 if x is greater than or equal to 2, and x plus 1 if x is less than 2. If a is equals to 2, then g of 2 is equals to 3. Because going back to the given, if x is greater than or equal to 2, then you will get 3. Second condition, the limit of g of x as x approaches to 2, first, you will get the right hand and left hand. If a is equals to 2, then g of 2 is equals to a. Therefore, g of a exists. Second condition, if a is equals to 2, then g of 2 is equals to 3. Therefore, g of a exists. Second condition, the limit if a is equals to 2, then g of 2 is equals to 3. Therefore, g of a exists. Second condition, the limit of g of x as x approaches to 2. First, you will get the right-hand limit. Limit of 3 as x approaches to 2 is equals to 3. And the left-hand limit, which is the limit of x plus 1 as x approaches to 2. You will substitute 2 to the given x. 2 plus 1 is equals to 3. Therefore, the limit of g of x as x approaches to 2 exists and it is 3. Third condition, the limit of g of x must be equal to g of a. In this case, the limit of g of x is equals to 3 and g of a is equals to 3. The g of x is continuous at 2. Example number 2. Given the piecewise function of m of x is equals to 2x minus 2 if x is less than 6 and 10 if x is greater than or equal to 6. If x is equals to 6, then m of 6 is equals to 10. Therefore, m of a exists. Second condition, the limit of m of x as x approaches to a, you must get the left-hand limit and the right-hand limit. For the left-hand limit, we have limit of 2x minus 2 as x approaches to 6. You must substitute the value of x. You will get 2 times 6 minus 2 is equals to 10. And for the right-hand limit, the limit of 10 as x approaches to 6 is equals to 10. Therefore, your limit exists and it is 10. Third condition, the limit of f of x must be equal to f of a. In this case, the limit of f of x is 10 and f of a is 10. Therefore, m of x is continuous at 6. Example number 3. Given the piecewise function of j of x is equals to 3x minus 2 if x is less than 5 and 2x plus 3 if x is greater than or equal to 5. If x is equal to 5, then j of a is equals to 2x plus 3, and substitute the value of x, which is 5, you will have 2 times 5 plus 3 is equals to 13. Therefore, j of a exists. Second condition, the limit of j of x as x for the right-hand limit, we have the limit of 2x plus 3 as x approaches to 5. Substitute the value of x. So we have 2 times 5 plus 3 is equals to 13. Second, we have the left-hand limit. The limit of 3x minus 2 as x approaches to 5. Substitute the value of x. 3 times 5 minus 2 is equals to 13. Therefore, the limit exists. And the limit of j of x as x approaches to a is equals to 13. Third condition, the limit of j of x must be equal to j of a. In this case, the limit of j of x The second part of this video tutorial is about the types of discontinuity. We have two types of discontinuity. First is the removable discontinuity and the essential discontinuity. Under the essential discontinuity are jump discontinuity and infinite discontinuity. The discontinuity is removable if f of x and f of a exist but they are not equal. And second, can be fixed by redefining the function. Example, given the function of q of x is equal to 3x minus 5 if x is not equal to 1 and 2 if x is equal to 1. If x is equal to 1, then q of 1 is equal to 2. Therefore, q of a exists. Second condition, the limit of 3x minus 5 as x approaches to 1, substitute the value of x to 3 times 1 minus 5 is equal to negative 2. Third condition, the limit of q of x must be equal to the limit of q of a. In this case, the limit of q of x is not equal to q of a. Therefore, q of x is discontinuous at 1. The second type of discontinuity is essential discontinuity. Under essential discontinuity are jump discontinuity. Jump discontinuity means if both one-sided limits exist but have different values, and if the function is approaching different values depending on the direction x is coming. Example, c of x is equals to 3x plus 1 if x is less than or equal to 1. And example, c of x is equals to 3x plus 1 if x is less than or equal to 1, and 2x plus 1 if x is greater than 1. If x is equals to 1, then c of 1 is equals to 3x plus 1. Substitute the value of x. 3 times 1 plus 1 is equals to 4. Therefore, c of a exists. Second condition, the limit of c of x as x approaches to a. First, you will get the left-hand limit and the right-hand limit. The left-hand limit is limit of 3x plus 1 as x approaches to 1. Substitute the value of x. 3 times 1 plus 1 is equals to 4. And the right-hand limit is the limit of 2x plus 1 as x approaches to 1. Substitute the value of x. 2 times 1 plus 1 is equals to 3. Therefore, the limit of c of does not exist. The second type of essential discontinuity is infinite discontinuity. Infinite discontinuity if both one-sided limits are infinite, and if a function that doesn't approach a particular finite value, the limit does not exist. Example, k of x is equals to 1 all over x plus 1 if x is not equal to negative 2, and 0 if x is equal to 2. If x is equals to 2, then k of 2 is equals to 0. Therefore, k of a exists. Second condition, the limit of k of x as x approaches to negative 2 from the left. Second condition, limit of k of x as x approaches to negative 2 from the left. Suppose that x is equals to negative 3, negative 2.5, negative 2.1, negative 2.001. Then the k of x is equals to negative 1, negative 2, negative 10, and negative 1000.